problem 16, we've got a rectangular page that's got 28 square inches of print. Margins at top and bottom page are 2 inches. Margins on the side are 0.5 inch. What should the dimensions of the page in inches be to use the least amount of paper? So this is going to end up being a parabola, and we're going to be finding the y-coordinate of the vertex. So let's sketch a picture here. So we've got this page, and it's got margins, bigger margins at the top than at the sides. And we want to know the dimensions of the page. So the page dimensions. So, well, why don't we let x and y be the dimensions of the printed portion? And then this is 2 up here and 2 down here. So margins at the top and the bottom. And then 0.5 on the right and left. So then we know that length times width for the page, so length is going to be x plus 0.5 plus 0.5, so x plus 1 times y plus 2 plus 2, y plus 4. Those are going to be the dimensions of the page. We know it's got 28 square inches of print, so the print is x by y. So we know xy is equal to 28. So what we want to do is we want to use the least amount of paper. This is the amount of paper. So we want to minimize that. So we're going to minimize the area, which is x plus 1, y plus 4. And it's going to be subject to the restriction of 28 inches of print. So there. And remember, we want to get this down to one variable, so we want to solve the second equation for y in terms of x. So divide off the x on both sides. So we get y is 28 over x. So then rewrite that. So this will be x plus 1. And then our y is 28 over x, so 28 over x plus 4. And let's go ahead and multiply that out. So first terms, x times 28 over x, the x's will cancel, 28. Outer terms, 4x. Inner terms, 28 over x. And then last terms, 4. So we can rewrite that as 4x plus 28 and 4 is 32, and then plus 28 over x. So we want to minimize that. And then, of course, our domain here is going to be x greater than 0. So let's go ahead and put this into Desmos and see if we can find that minimum. So 4x plus 32, and then plus 28 divided by x. So let's zoom out here. So let's see, we are seeing a function with a maximum. We want the portion that is greater than 0. So there's going to be another portion of this graph. There it is. Okay, so let's go to the graph settings. Let's set our domain here on the x-axis. So it's going to be 0. And then let's not go up to 320. Let's try 25. Yeah, that's not bad. Let's try 15. 10. And let's see here on our y-axis, so let's go ahead and do 0. And instead of 200, let's maybe do 50. That didn't get it. There we go. Okay, so actually let's make this a little bit smaller so we can see those axes. So -1 and x, -1. So now we've got our axes. So and what we want to do is we want to find the vertex point here, which is the lowest point. And that is approximately 2.646 and then 51.166. So there's our Desmos graph. And our minimum here, it looks like x is approximately 2.646 and y is approximately 53.166. So then let's see our minimized area. So that's going to be the length of the printed area. So then the length of the page is going to be x plus 1, y plus 4. So x plus 1 is equal to 3 point, we're doing 2 decimal places, so 65. And then y plus 4 would be 53 plus 4, 57.166 would be 17. So that would be the least amount of paper. That's dimensions. So they didn't ask us what would be the area. If they asked the area, we would just multiply these two together.